right, cool. So today we are going to be talking about loops, another fundamental piece of computer science or programming. Um, so if you look, this is the Lovely Seats application that we built, I don't know, 2 lessons ago when we were talking about strings and stuff. If you look, we have a lot of repeated code. Like a lot of this stuff is repeated. And what loops are going to do, loops are going to allow us to, instead of having customer one and customer two, have thousands of customers create thousands of purchases. So loops allow you to take a list of things and iterate over that list, or while a condition is true, run a certain set of functions and subfunctions. So we're about halfway through Python at this point, and what I want to reiterate to you now, from a computer science perspective, is that remember, coding is just the tool, right? So coding is the hammer, it's the screwdriver, the loops are the screws and nails. Computer science itself, you have to look at a problem to solve and solve that problem using the tools of coding. Okay, you can go through this whole process of learning Python with me and Kevin here and never really truly understand, well, okay, what can I build with it? What can I do with it? Okay, I learned all the syntax. I learned how to code. Well, what am I actually doing with it? You have to take the next step after this. After we get done with Python, we're going to get into computer science concepts like data analytics and that kind of stuff. Before then, I really want you to think, how do I solve a problem, right? So, in when I don't mean a large, grandiose problem. How do we solve world hunger? What I mean is, um, I have a list of customers, and how do I add the addresses to those customers? How do I add phone numbers to those customers? And then, how do how do I find a way to sort through all of my customers to find out who's ordered the most amount of stuff for me and when did they order it? How many orders do I have open? How many orders per hour do I have? Like, these are very small problems that coding can solve, but computer science in general helps solve larger problems. And I understand, for some of you, including myself, we're at the very precipice, meaning the very beginning. We're at the very edge of computer science. If you go further into computer science, you're going to learn that it's very married to mathematics, and that you're going to want to pick yourself up like an algebra book, calculus book, a trig, a finite mathematics book, a statistics book. Like, you're going to want to pick these things up, and you're going to want to learn them on your own. Um, I came out of high school. I didn't have a very strong mathematical background, but I loved math. But I thought, oh, I can easily pick up mathematics. So I don't really need to learn it because I can just learn it when I need to learn it because it just makes so much sense to me. Well, unfortunately, had I paid more attention to mathematics and I really developed that skill set and kept with it over the years, then a lot of computer science concepts would have been completely trivial. But instead, I had to learn them the hard way. I didn't realize I was looking at mathematics. I didn't realize I was looking at a quadratic equation until I went back and I reviewed what a quadratic equation was. And then I go, oh my God, that's what my function is doing. So try to keep this in mind, that we are giving you the tools, but ultimately the next step you're going to have to take is critical thinking. And maybe that's something that as alumni we can do together and have critical thinking sessions. Code Wars is a fantastic website that you can use to challenge yourself on coding, but also critical thinking, which is a huge part of computer science. Now, we'll add that to our resource pool and sort of we'll continue on after we're done with Python and we're done with our computer science course. We will continue on making videos on these coding challenges and critical thinking, but we'll do so not just me sitting here talking at you. Instead, it'll be, you know, group sponsored. So I'll probably grab like 4 or 5 other alumni and we'll have no idea what we're doing, and we're going to get in there. We're going to try to figure it out. We're not all of us are geniuses. Like I said, I'm a bit of a layman. I come from the simpler side. But if you put 4 or 5 people together to solve a problem, you're going to get a solution. It may not be the most elegant solution, and we may learn how to build the most elegant solution together. But it'll be a solution. And in the real world, that's how it works. You need a solution to a problem. And that's what you're going to get paid for. Solving problems. And this is, again, this is just a tool that's a piece of computer science. So with that being said, let us continue on to loops. I'm excited for this. Loops is such a huge part of my everyday life when I'm building functions for work. I do a lot of infrastructure code. A lot of infrastructure code means I have lots of lists of servers, lots of lists of config files, lots of lists of queries that I have to run over multiple things and I have to loop through. So we'll have Kevin on in a little bit. He'll probably help us with some of these exercises. But what we'll focus on right now is a loop is just iteration. We're going to go over a list of things, and instead of, for example, in this example here, instead of printing out each index of dog breeds, what we're going to do is we're going to iterate over it and print out each piece of this. Because we don't want to print out the list, we want to print out each of these individually. So if we run this code here and we print out dog breeds, okay, and I run this little snippet of code, well, what if I want to stop whenever I find a poodle and I don't want to go any further in the list? Well, currently right now, this list doesn't give me the opportunity to. I can't write a condition in here. I can write a condition that, that a non-function condition that says if dog breeds, if dog breeds has poodle in it, then write poodle back to me. But that's not very efficient when we're dealing with large list of things. So paste the following code into the script. Okay, we're going to paste the following code. So here it says for breed in dog breeds, and I stress that breed here is a temporary variable because I could change this to I and change this to I and print this out and it would print out the same. Okay, and then let's redo this and rerun this, and you'll see that it comes out the same each time. It prints out, each line prints out what was stored in that list. So the loop, this is a for loop, and it says for temporary variable breed in dog breeds. So what it's really saying is for each item that's in dog breeds, and dog breeds has 1, 2, 3, 4, 5 items, or 4 indexes, 0, 1, 2, 3, 4. Has 5 indexes, numbered 0, 1, 2, 3, 4. So what this temporary variable is saying for each, is really saying for each index in the list dog breeds, print out each of those indexes one by one. Okay, so let's go to the next one. So create a for loop. All right, let's see what they want us to do. We can read over some of this stuff. The general way of writing a for loop is for temporary variable in list variable. So the list variable, the name of the list, do something, right? So for I, and look, they actually did what I did in the previous example. For I and dogs print I is the same as saying for dog and dog breeds print dog. So for I and dog breeds print I is the same as for dog and dog breeds print dog. Dog is temporary. I is temporary. It doesn't matter what you put there. Okay? As long as it's not another declared variable that's been defined somewhere else in memory, it doesn't matter. It's just a temporary thing. Okay? So let's run the code. We should get an indent error, which we do. Indent line 6 so that you won't get an indent error. So what's important is inside of the for statement, this print has to be nested. And we run it and we get, so write a loop that prints each sport and sport game. So here's our list of sport games. And really, again, we're starting off with loops, but I'm going to promise you, this is going to turn into functions, right? And what I mean by that is, based on what we know about functions already, we can define something called sports that takes in a list, right? And prints, and then we can put our loop in here that says for sport in list, right? Print sport. And then what we could do down here is we can then run sports, and we should really put another enter here. We run sports, okay? The function we just created, which that's a bad name for a function. It should be print sports. That's a better name for a function. So it should be print sports. Okay, so for print sports, we can just enter the name of the list. And we can run it. And print sport is for each sport in sport. Oh, our print statement was incorrect. Ha! Look at that. So, okay, so this is the way we would do it in the real world. Let's make this shorter. So what they were looking for, realistically, was for us to type in for sport in sport games, print sport. This is what they wanted. They wanted this little snippet that we created here. But in reality, because we're now programmers, we should be thinking that why would I ever write something to be used only once? Now I have this function. I can use this as many times as I want, and it'll always print out an item in a list. And here, so not only does this function work for sport games, right? But we could take board games and we could stick board games in this function. And then we can run this, and look, it prints out the board games. So it prints out the board games, and then using the same function, sports games is not defined, sports, because it's not plural. This is why you have QAs. It prints out the sports, and it prints out the board games. So really, print sports can be changed to print list. Look at that, print list. And again, it's out of scope of what Codecademy is asking us to do. But as programmers, we should be thinking about this. So here's the board games, and then here's the board games with the sports, and then here are just the sports. All within a function. So instead of writing those two loops, look at this. We write a function and just call that function. Super simple. Okay, let's move on to the next one. Using range and loops. Okay, so we talked about ranges. Ranges are we start at a index or a number, and we go to another index or number. So if we start at the range 0 and we move to range 5, it will start at index 0 and it will end at range 5. I think inclusive. So for example, if we wanted to print out warning message 3 times, we'd want to say something like this. For I in a list of length 3, print warning. Notice we need to iterate through a list of length, but we don't care about what the list is. To create the list of length n, we can use the range function. Takes the number as n and input returns 0 to n minus 1. For example, 0 through 5 is equal to range 6. Okay. 0 through 1 is equal to range 2. So remember this n minus 1 little formula that we talked about? So if you want the fifth range, you only want to go to index number 5. You have to range up to index 6. So it'll exclude 6, but it'll count up to 5. And the reason why is because, remember, the 0 counts as the first position. So technically 1, 2, 3, 4, 5, and 6. So it ranges to 6. So an easy way to accomplish this would be, for I in range 3, print warning. And this will cover index 0, index 1, and index 2, which if you count on your hand, 0, 1, and 2, that's 3 total indexes, will print warning 3 times. So let's see, use range function in a for loop to print out promise 5 times. So for, okay, I in range, so 5 times would be 5 indexes, or 4 indexes, 0, 1, 2, 3, 4. So range of 4 would print out, we want 5 times, right? So in range 5, yeah. And then we'd print promise. Or return promise. Let's check it. 1, 2, 3, 4, 5. Yep. Easy peasy. Next one. Infinite loops. We've iterated through the list to have discrete beginning and end. So discrete means we know where it starts and we know where it ends. So non-discrete means it's ambiguous, or it can start anywhere or end anywhere. So let's look at this loop. It says what happens there. My favorite numbers are 4 through 42, 4, 8, 15, 16, 42. For number in my favorite numbers, so for each of these, my favorite numbers append to 1. So what's interesting here is that it adds 1 to this list every time it iterates through. So it'll go on forever. So when it hits 4, it'll add 1. It'll hit 8, it'll add an additional 1. 15, an additional 1. 16, an additional 1. 42. What I mean by that is, if we look at this list, when it prints out, when it loops through the first time, it adds 1 to the end of it. When it loops through the second time, and the third time, and the fourth time, so when it hits 4, it creates a 1. When it hits 8, it creates a 1. When it hits 15, it creates a 1. When it hits 16, it creates a 1. It's 42, it creates a 1, and then it hits this 1, which then creates another 1. The loop will never end. It'll keep adding 1s to this list, so your list will end up looking something like this to infinity. So the loop will never finish. That's what they're talking about here. A program that hits an infinite loop often becomes completely unusable. The best course of action is to never write an infinite loop. I can attest to that. But if you accidentally stumble upon into one, you can end the loop by pressing Control-C to terminate the program. And this is especially true in PowerShell. So for example, we'll use the Python method here. We'll type in Python, and then we'll paste in the code. And we'll run the code, and you see that the Python interpreter can never finish. It's thinking about it. It's actually eating up memory in my system until I press Control-C. And then when I press Control-C, it should kill the script off. Now the problem is the loop's running away right now. Keyboard is interrupted, the last call. So what happened was the memory in my computer was being filled up with these bits of 1s. To infinity until I ran out of memory on my computer. So what I did was I held down Control and pressed C, and that interrupted the Python from running. Suppose we have two lists of students, student period A, student period B. We want to combine all students into period B. Write a for loop that goes through each student in period A and then adds at the end of period B. So for student in students, we want to students period A. Okay. What they want to do is we want to add it to the end of students period B. So we already know how to do that, right? we're going to return students period B dot append student. So every time a student from student 8 Alex will be here. It'll say for each Alex in students period A, return students period B, and then add Alex to the end of period B. So let's go ahead and run this. We get, did I misspell students? Return outside the function. What? Did I write? Let's see. No, that looks right, right? For student in students period A. What did I do wrong? It looks right. Let's rerun this. Return outside of the function. Oh, parenthesis. Well, I guess we don't have to return anything. I guess that's where my error is actually. My error is that I'm just supposed to append students B. And then once I'm outside of the loop, I'm going to print students period B. So once this loop finishes, I want to see what's in period B. I know, so let's do this actually. So we're going to print students period B before the loop. Okay. And then we're going to print it after the loop. So it'll print twice. And let's run this. And so the first time it prints out the normal list, and the second time it prints out this list plus this list. Inside the for loop, after appending the student, print student. Okay, so let's get rid of our little unit test here. So inside the loop, after appending, they want to print student. So we're going to print the student. So this is gonna tell us which students that we're adding. Nope. Print student. What did I do wrong? Expected to see Alex Brianna printed on new lines. I agree that it definitely should have printed this. Right loop that goes through inside the loop, appending student, print student. This should be correct. Let's do this. And let's retype this. Maybe there was an indentation error. I don't know. Unindent does not match outer indentation level. So what? Let's just run this. See what happens. Okay. Hit enter, and then we'll hit print student. And indentation error again. This is just silly. I think this is just Codecademy. Let's rerun this. Nope. So let's rewrite this whole thing. This is so silly. For student in student period A, okay, we're going to take students period B and we're going to append a student to it, okay? And then we're going to print student and we're going to run. See? I mean, it looks the exact same to me. I may have done something else. Maybe I forgot a parenthesis or something. I don't know. Whatever. This is what it's supposed to look like. It prints out each of the students that it's being added to the list. And again, let's see. What does it say? Let's suppose you made a typo in the body of your loop. Oh no, inside the for loop, change the object of the append from students period B to students period A. Now you're adding each student period A to period A. This will be infinite. Refresh the page or something to escape this infinite loop. Okay, let's just... So they want us to make an infinite loop. I'm not going to do it. What they wanted us to do was to change students period A, to take this students period A and move it down to here. And essentially, you're saying for each thing in a list, add another thing to the list. It'll go on forever. It'll never stop. So having to fare the infinite loops instilled in you, change the inner students A period back to students B and revel in your safety and cleverness. So just keep it as is. And again, guys, we could listen, we can make a function out of this, right? We can say, okay, so let's critically think, what is this thing doing? So the indentation on this is list. I feel like it won't let us write a function, whatever. Let's do it above this then. Yeah. Okay. So let's take a look at this here. So what is this doing? We're taking a list and we're taking each part of the list and we're adding it to another list. So what we're doing is we're append list, and it's taking in a list 1 and a list 2, right? And it's saying that we're going to append list 2 with a list 1. So for item in list LST1, right? We're gonna take the first list. We're going to then take the second list and append each item from list 1 into list 2. Okay? Then we're gonna print out each item. Okay? And then we're gonna exit the loop. So we need to be back down here. We're going to exit the loop. And then when we exit the loop, we want to print list 2. And that'll be our final list. And so let's go ahead and call our function. So we're going to append. So silly. Append. This should be outside. So we're going to append list. And we're going to take in the first list with the students A, period A, and our second list, students, period B, and we're going to elongate this here. And so this is our function call. We're going to cut all this out right now, and we're going to run this. And when we run it, we see a couple things happen. First, it runs our normal loop, which just adds each of the items from list 1 into list 2. It shows you what it's adding. It's adding Alex, Brianna, Cheryl, and Danielle to list 2. List 2 happens to be students period B. And then finally, we're printing out list 2 to validate that that list is solid. So again, when you're looking at this stuff, try to create functions, because now it doesn't matter if it's students period A, students period B, if it's division west or division east, if it's grocery list and shopping list, we can now append 2 lists together, right? So it's a repeatable code. All right. We often want to use a loop to search through a list for some value. Here's the example. For item and item on sale. If the item is equal to knit dress, print out knit dresses on sale. So this is saying search through this list, and if you happen to find an item called knit dress, then do this, print this out. Okay? Now this is talking about a break. You can stop a loop from inside the loop by using a break statement. So the break statement is we find the thing that we need and we want to end the loop. So there's a statement called break. And if we look, here's they put it. They say, if you find an item in the list called knit dress, then stop the loop. Okay? Stop the loop and print at the end of search. Okay? Now, for items, print item. If item is knit dress, you would print a message that says, I found a knit dress. And then break, meaning stop the loop, and then end of search. This will produce. Okay, so let's just practice this. You have a list of dog breeds. You can adopt dog breeds available for adoption. Using the loop, iterate through dog breeds and print out each dog in the dog breeds. Again, we're gonna create a function. In that function, we're gonna look at what this wants us to do, and this wants us to find a dog breed. So we're gonna just say, instead of find dog breed, we're just gonna say we're gonna find item, and we're gonna pass into it a list. Okay, a list, and then we're gonna pass into an item, the thing we want to find. And I don't know why that just did that. Oh, Codecademy, you guys can do better than this. Come on. All right. That was actually my fault, not their fault. Okay. So let's look at the requirements here. It says using a loop for item in list. Okay. Iterate through the list and print out each dog breed. We're going to print item. Okay. And then let's go ahead and let's set up our function call, because I feel like that's pretty important right now. Okay. So find item. And our parameters are the list, which is this huge thing here. Unnecessary, the name of the list. And let's elongate this again. Okay, so that's the first thing, and then the next thing we're supposed to look for is item, or the thing that we're looking for. So what we can do right now is we can get rid of this because it's not part of our requirements for this first step, and we just run this and it prints out a list. Now if you were to do this outside of the function, meaning say you just wanted to write the loop, you would just say for dog in, you know, dog breeds available, you know, print dog, and it would be this simple. But we're programmers. We're gonna set up a function for this because we don't have to want to repeat ourselves, right? So inside our loop, after you print each dog breed, check to see if it is equal to the dog breed I want. If so, print they have the dog I want. So let's add a second parameter here called dog or item. Okay. Or let's not even put item. Should we put item? I guess yes, because this is a temporary variable. We need to bring in something other than that. Let's just put in, so instead of item in list, for each, no, item in list is good. We get a list and we want, so what's another word for something that we want? Our target. So I'm gonna type in target, okay, like a bullseye target, right? And so it says inside our loop, after you print each dog breed, okay, check if it's equal to the dog breed I want. So if, okay, the item that we're looping through is equal to the target that I want, then print, okay, in this case, a very specific statement. They have the dog I want. Yeah. And let's rerun the code and positional argument on target, missing one require. Oh, because we never called. So down here on this function, we never called the dog breed I underscore want. And let's rerun this. And French Bulldog Dalmatian, they have the dog I want, which is Dalmatian. So here, they want us to add a break statement here. So let's rerun this. And it prints out French Bulldog Dalmatian. They have the dog I want, and then it stops the loop. Okay, so this is how we did it in a function. So how would we do it the way that Codecademy would want us to do it? Again, we would say for dog and dog breeds, you know, print dog if dog is equal to the dog breed I want. And I know this is hard to see. Let me scroll. I was looking at requirements. Dog breed I want. Dog breed I want. Let's spell it correctly. Then print the message. They have the dog I want. And then break. So this is the requirements from Codecademy. Let's run this. And if dog breed I want, name error, dog bred. I spelled it wrong. Run. So here's the second statement. So if we comment out our function call and we just run it, it's the exact same. So again, I want you to get in the mindset of looking at everything from a function perspective, because we can reuse this. In fact, what we could do is we could print message, and you're like, what are you talking about, print message? We can enter in the message as a parameter. And we can say message is equal to they have the dog I want. And down here, when we enter the parameters, this is starting to get pretty thin. We just add message as the parameter, and then we run it, and look, it's the same thing comes out. So we wrote a function that takes a list, takes a thing that you want to find in a list, and print and a message as a parameter. It's saying, here's a list of stuff. Here's something that should be in that list. If it's in that list, I want you to print out this message. So again, we can now expand this beyond dogs, right? This doesn't have to be the dog. Like, I could put any list in there, and then I could put any target of something that should exist on that list. And then I can write any message that says, if you find that thing, print back out this message. So this is functional. This is reusable. This is critical thinking. This is computer science. This is where the stuff starts to get really cool. When you start breaking stuff down like this. And I know this is like, for you more experienced coders out there who are watching this, you're laughing because you're like, no, duh. But you got to understand, when I started coding, this is not, this is a huge breakthrough. Or this was a huge breakthrough for me. When I started to realize that, oh, I'm looking at inputs and outputs. Well, how can I take inputs and create, usable outputs? This didn't come naturally. This came after much practice. All right, let's move on. So continue. While we're iterating through lists, we may want to skip some values. Let's say we want to print out all the numbers in a list unless they are negative. We can use the continue to move on to the next I in the list. So here's an example. Big number list. For I in a big number list, if I is less than 0, then continue print I. This would produce 1, 2, 4, 5, 2. And if you look, 1, 2, it would skip over -1, and -5, and -9. So this is a good way to check a list for conditional values greater than equal to other conditional values. So let's get right into it. Your computer is the doorman at a bar in a country where the drinking age is 21. Loop through the age list. If the entry list is less than 21, skip it. If it is, we move on to the next entry. Otherwise, print the age. Okay. So let's start with their requirements. For age and ages, remember age is just temporary. If age is less than 21, continue. You can skip it pretty much. And then I guess, I don't know if you put an else statement in here. It looks like they did not put an else statement. They just decided, okay, well, print age, I guess, and let's run this. And this works. And again, this is another thing we can functionize. We can functionize. We won't because this is super quick, but you can create a function for this, which I'm sure we'll do later on. So let's talk about while loops. Now we've seemed to use a lot of example of for loops, right? For something in a list of something. There's another type of loop we can use called a while loop. While loop performs a set of code until some condition is reached. So let's look at an example. Index is equal to 0. So they're starting with what's called a counter, meaning a variable that has a set value equal to 0. And they say while the index is less than the length of dog breeds, so what they're doing is they're counting up the length of this. So this is, the length is 1, 2, 3, 4, 5. So dog breeds length is 5. Print the dog breeds index, meaning index is 0. So it'll print out the first piece of dog breeds, which will be bulldog, will get printed out. And then take the index variable and add 1 to it. So the next time the loop goes around, it says, is 1 less than 5 now? Remember, it started at 0. It said, is 0 less than 5? Yes. Do all of this stuff and then increase this by 1. And now index is 1. Go through this list and increase this by 1. Now index is 2. Is 2 less than 5? Yes. Keep going. And then finally, it'll get to 5, and it'll say, is 5 less than 5? No. Then stop. Then skip over this whole statement. Okay? So let's go ahead and try this out. You are adding students to a poetry class, the size of which is capped at 6. While the length of students in poetry list is less than 6, so we already know we can write a conditional statement, right? While students in poetry list is dot length, so the length of this and end is less than 6. Use dot pop to take a student off all students list. So students, all students, dot pop removes to take a student off all the list and then add it to the students poetry list. So if it's less than 6, use dot pop to take a student off of all students list. Huh. I don't know if we can do this. You know what? Let's try something here. Let's take a look. Let's say new student is equal to all students dot pop. And let's find out what happens when we run this. We're going to try to print new student. I'm going to see if, so we're expecting Loki to be stored in a new student. And no. Well, I got to be able to spell correctly. Name all students. So let's run this. It does. That's interesting. So we can store whatever gets popped temporarily into a variable. So we can create a variable called student is equal to all students, which is this huge list, pop. So pop means we're going to take the last one off of the list, and we're going to store it into the variable student. And then what we can do is we can take students in poetry. That is just cool. This is really cool. Poetry, and we can add it or append student to it, one at a time, right? And then just for good measure, let's just print out the student that we're adding. Okay, so let's run this. Print student again. I am so used to like lazy coding. All right, let's run this. So this is crazy. So let's get out of this while loop, right? All together. Let's get out of it and let's just print out students in poetry for our unit test. And what we should see is all of these students should now be in this list. How cool is that? Look at that. So this is awesome. So we took a list and we did a while loop that says I want to move 5 students from all students into poetry class. But I want to start with the last student that's in this list. So say for example this list was created based on the student's grades. And let's say Loki had the lowest grade. I want to take the kids with the lowest grades and put them into poetry class. Well, it goes through a list, it pops Loki off, puts it in the student, and then adds that student into the student's poetry list. And here we're just printing out the student that got added. And it shows you, okay, I'm adding these students to the poetry class, and then I'm printing out the students in the poetry class list, and you can see that we validated this. How cool is that? That is pretty gnarly. All right, so we have seen we can nested loops. We've seen how we can go through the elements of a list. What if we have a list made up of multiple lists? How can we loop through all the individual elements? Suppose that we're in charge of a science class that is split into 3 project teams. So here it's a list of 3 lists. List 1 is Ava, Samantha, and James. List 2 is Lucille, Zed. List 3 is Edgar and Gabriel. If we want to go through each student, we have to put a loop inside of another loop. So for each team in the project and for each student within that team, print student. So this is kind of the same as a for loop. Nothing fancy here. We have provided a list of sales data. So this is 3 lists. The first list is 12, 17, 22. Second list is 2, 10, 3. 5, 12, and 13 is the third list. Okay. That shows different number of flavors of ice cream sold at 3 different locations. At a fictional shop called Gilbert, we want to sum up the total number of scoops sold. Start by defining a variable called scoops. Okay, so scoops sold is equal to 0. Let's run it. Go through the sales data list and call each inner list location and print out each location. So for sales, I guess location in sales data, print the location. Let's run it. Okay, so the location, if you notice, is pretty much it's a tuple. It's a GPS coordinate. That's what it looks like, right? Like 12, 17, 22. It looks like a GPS. So what I'm assuming they want us to do is then, so print each location, and then for each, I want to say coordinate, or scoops sold. Scoops sold within sales data loop. So within this loop, go through and loop through each location list and add the element to your scoops sold variable. Okay, so I think what they're saying is for each go through each location list and add the element to your scoops sold variable. So for each, so for each item in I think they want us to do this for each item in the location. You should have the sum every, So I guess this is not GPS. This is actually the brackets represent a location and the numbers inside represent scoops sold. I think what they want us to do is they want to take a scoops sold and then add whatever the item is for item in location. And then I think outside of the loop, this is a really strange way to do this. We're going to reprint scoops sold and see if it runs. It says there's 96 scoops sold when you add up all these together. And print out the value of scoops sold. We already did that. I would definitely make this a function. And the function would just take in sales data as a list. Okay, so let's just try to build it. Okay, so let's try to build it down here. We would take in, so scoops sold would take in a list as the first parameter, right? And do we need anything else? I don't know. Let's just write it. We would say for each item in list, okay, and for each item in location. You know what? We would have to put in scoops. Scoops is where we started. So here scoops is going to be 0. So scoops sold will be 0. So we'll just say sold. So that way we can start any number. We can start at 96, and we can start with 96, and then we can add in that. So for each item in the list, and for each item in the location, for each, no, we're going to say for each scoop in item, okay, we're going to take scoops, so plus equal scoop. And you know what? Here, it looks like we'll have to print out scoop sold. Well, so scoops sold is going to be equal to scoops sold. I'm not sure we have to do that, but what I want to do is outside of the for loop, which I believe is here, I want to print out scoop sold for each item in the list. I don't know. Let's try it. Scoops. Oh. Scoops sold. And again, why is the editor doing this? Let's do home. Let's do sold parameter. The list will be sales data. We might have to move this over to Visual Studio Code. And our scoop sold is going to be 0. Let's run this. Yeah, indentation errors. BS. There's no indentation errors. It's that they won't allow us to run this. So here's what we'll do. We'll snag all of this. We'll move this over to Visual Studio Code real quick. And we'll create a new file call, and we'll save as ice cream. So let's go to projects, and let's go to basic functions. And we're going to say scoops. We're going to say ice cream. Ice cream scoops.py. And we'll paste all this in. And let's take a look. So there's no indentation problem here. Not at all, I don't think. So let's run this and see if we get a bug. Unindent does not match. So is this print statement here that was incorrect? Let's rerun this. Let's see if we get a unindent does not match any outer. So let's go back to this. And okay, yeah, this should be just inside of the def. So let's rerun this. Ha, it does work. So if we get rid of all of this and we just rerun this, we get 96, which is correct, right? But here's the cool part. With the way this function works, right, we can put 96 into here. And then when we run it, we get 192. So this function's reusable in the sense that we can start with any number of scoops sold. Let's say we've already sold 1,000 scoops of ice cream, and we're like, okay, how many scoops did we sell after today? Oh, we sold 1,096 after today based on this sales data. But again, we'll start this at 0 run. And what's even, I think, more impressive is you can run negative numbers. So let's say we're starting today with a negative $10 deficit from yesterday, meaning we didn't sell enough ice cream yesterday to make a profit. So we're starting today at negative 10. Based on this sales data, did we make any profit? Yes, we did. We made $86. Or we sold 86 ice cream scoops. And then we would multiply the 86 by whatever our number is. So there's a ton of stuff that you can do analytics-wise. We won't go too deep into that quite yet. All right, so we're almost done. Almost. Come on. We just got 2 more after this one. So list comprehensions. Let's say we have scraped a certain website and gotten these words. We want to make a new list called usernames that has a list of all the words with the @ symbol first. We know we can do this with a for loop. So here's the for loop. For words, if word 0. Oh, so it's taken. So what's interesting here is if word 0, word in words, meaning this word, at the first index is equal to @. So what's interesting is this guy here has how many indexes? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 indexes. So I want to show you something really quick. In Python. So let's create a variable called name, and we'll put my name in here, Jeff. Now if I type in name 0, I should get back J. So a string has an index value. So if I put in 1, I should get back E. And 2, I should get back F. And 3, I should get back F. Jeff. So each one of these letters is an index within this variable. Okay? So based on that, let's see. First, we want to create a new empty list called usernames, and as we loop through the word list, we want to add every word that matched our criteria to usernames to look like this. Print usernames. And, okay, cool. So let's get to this. This list comprehension takes elements in words, assigns the element into a variable called word, checks if the word repeats steps 1, 3. Nice and simple. So let's do our little bit. We have defined a list heights of a visitor to a theme park. A list heights of visitors to a theme park. In order to ride the Topsy-Turvy Tumbletron roller coaster, you need to be above 161 centimeters. Using the list comprehension, create a new list called Can Ride Coaster. And we're going to make it an empty list right now. It has every element from the heights that is greater than 61. Okay, so for height in heights, okay, if, and I don't, like, what's interesting is we don't, like, this is, I don't know, if height is greater than 161, ride coaster dot append height. This is so silly. Because I feel like, okay, this will do it. Like, this will. Can ride coaster is not defined. Can ride coaster. Because I misspelled this. And then print. Print. Can ride coaster. Yeah, indentation error because you won't let me backspace it. Alright. Okay. So I don't know if we did this correctly. And what I'm saying by that is they're showing us that list comprehension is here. Usernames is equal to word for word in words if word is equal to 0. So, okay. So they're saying that we need to create this shorthand. So what we did is we did it the long way around. So they're saying, okay, create the list, and inside the list, we're going to say height for height in heights, okay, if height is greater than 161. Holy smokes. So let's get rid of this little for loop that we built. And let's run this. And it does the same thing. So mind is blown now, but so this is shorthand. So for this, let's back out. Let's go look at that loop we built, right? So this is the loop we built. Okay? And this loop we built works, but this is the shorthand for it. which is odd because Swift actually has something very similar. If you've coded Swift at all, you know that there's something I believe called unary, a unary variable that does something very similar to this. Um, and it's shorthand. It says, okay, we're gonna define height, and then we're gonna write the loop here for height and height if height is greater than 161. So it's going to store anything greater than 161 into the variable height and then repopulate this list for each item, which it did here. 164, 170, 163, 163. That is nuts. Wow. Okay. So we're going to have to practice that. So more list comprehensions. Let's say we're working with usernames list from the last exercise. We want to create a new list within the string, please follow me. We add it to the end of each username. We want to call the new list messages. We can use a list comprehension to make the list with one line. Users plus please follow me for user and usernames. Okay, simple enough. The list, okay. Let's just go back to the exercise. We have provided a list of temperatures in Celsius using a list comprehension. Yay. Create a new list called Fahrenheit. Oh my god, I can't spell. Fahrenheit. New list. Okay. It converts each element into Celsius. Oh. So each element's going to be called temp for each temp in Celsius. Okay, so for each temp in Celsius, can we say temp times 9 divided by 5? I'm sure this has got to be wrong, but I'm not even thinking about it. My mind is so blown right now. So for each temperature in Celsius, which 0, 10, 15, 32, -5, 27, and 3, take that temp and multiply it by 9 divided by 5. So Fahrenheit is equal to Celsius times 9 plus 32. So now this is convenient because I don't think we have to make an expression out of this. I don't think we have to make an expression that looks like this. Let's run this. Temp is not defined. Temp is not defined. Temp is, yeah, temp. Oh. Well, Fahrenheit. Okay, this is confusing. So I guess we have to put the list name Fahrenheit for temp. Fahrenheit. God, I can't spell. Let's run this. Temp is not going to be defined because run. Oh, where's temp? And let's run. Oh, so I'm going to copy this Fahrenheit here and just paste it everywhere because if there's one thing I cannot do, it's spell. And run. Fahrenheit is not defined. Okay, let's look at the example again. So it says messages user. Here we're doing Fahrenheit temp. Right? And then and honestly it should be temp. For each temp in Celsius, right, we should multiply this and we should print Fahrenheit. That looks correct. Fahrenheit is not defined. Interesting. So I wonder if putting the parentheses caused issues here. Technically, in this example, we don't need them, but I wonder. temp run. Invalid syntax. Celsius. In Celsius. Temp run. Huh. Incorrect. So I'm going to reset the exercise. Bam. And then I'm going to re-go over this. We want to create a new list with the string, please follow me, added to the end of each username. We want to call this new list messages, right? We can use a list comprehension to make this list one line. Here, they have a new list called messages. Here we want Fahrenheit. Okay. And in their example, they are saying that user plus please follow me for user and usernames. So the output should be it concatenates the string. So I wonder if they want both the Celsius value and the Fahrenheit. We want to add 100 to each value. We can accomplish the goal in one line. Updated votes, vote value plus 100 for vote value in my upvotes. Right? So this is kind of, oh, you know what? So temp times 5 divided by 9 plus 32. We have to do that operation first for each temp in Celsius, I think. So, wow. So this is this is crazy. So this is like a reverse logic. Let's print this out. See if this passes first, and then I'll explain it. You may have already got it. Values did not match 32.0, 50.0, 5. It's because it's 9 divided by 5. It's not 5 divided by 9. Come on. And it matches, it passes. Okay. This is blowing my mind here, guys. Honestly, like I said, I've seen this in Swift, something similar, but let's expand this out. So what you have to do is okay, so in the for loop, you have the for something in list. Then you have an action. You would say something times 9 divided by 5 plus 32, like return something time, right? And you would get back a value for each thing from the list you're putting in. And what this is saying is create a list of Fahrenheit. So the problem is we would have to create an empty list called Fahrenheit. So for here, we would have to define, we're just going to say Fahrenheit is F height as an empty list, right? And then we would have to say inside of our loop, F height plus equals this. And we would feed in all of the Celsius numbers into this list. So what we would do is we would say, let's get rid of all. No, let's do this. We would say define convert temp convert C to F. It would take in a list, and in that list, okay, we would have Fahrenheit. Okay, for something in list, Fahrenheit, we would add something which, yeah. And then we would print, when we're done with the list, we would print F height, right? And then let's test it. To F, and then we would put in the list, which would be Celsius. And what we're going to do is we're going to comment that out. We're going to run this and float. Ah, Because it converts it into a float. Convert C to F. Fairness type error float. Object is not iterable. What we could do is we can enforce a string on this. str maybe. And we could store it as a string if we wanted to, just for funsies. Cool. And we did. And what's interesting here is it took even the periods of the floats 32.0. Oh, we shouldn't do it to string. We should say something in list should equal to this. What we should do is we could force this into an integer. This is so bad, but we'll run this. So integer object is not iterable. I guess we could just append it, right? What we could do is we could say temp is equal to this, and then we can say fheight dot append, and then we can put temp, and then we can run it. And okay, so that's our sort of bootleg way to do it. So this is a function that does the conversion from Celsius to Fahrenheit. So notice how we put the calculations underneath the for loop. Inside of this shorthand, essentially what they did was they put the calculation before the for loop. And then the loop runs over each item and applies this calculation to this. Okay? So look at how many lines of code were saved by writing it this way. 1, 2, 3, 4, 5, 6 total lines of code were saved. Really, it's 5 because you would have to print out Fahrenheit, right? To get a response back. But that's amazing. That is amazing. Look at this. It prints the same exact list. That is nuts and awesome, and that is something we should definitely take advantage of. Cool. And so here is our last thing before our next video, and we did 11 out of 11. So let's go ahead and create a list called single digits is equal to consists of the numbers 9 through 0, 0 through 9, inclusive. So I think it wants 10. And then we're going to write our unit test down here. Right? And our first unit test should be 0 through 9. And then print single digits. And then run it. And range. Single digit equals range 0 through 10. Is there a way to convert this to a list? Is it? It's probably not this, but probably not. Nope. That is expected output 0, 1, 2. Yeah, I expected output 2. Delete end back 0. As we run this. Yeah, so this one's 10. Let's run. Let's cancel this. Let's rerun this, see if we get an error. So let's double check something real quick. How to create a list from a range in Python. Let's take a look. Always forgetting, man. It's just little things. You gotta put list. We've done this how many times? And let's run this. And expect the exprint to print output 0. 0 through 9. This is printing out 0 through 9. as far as I'm concerned. That's correct. Okay, so create a for loop that goes through the single digits and prints out each one. So I'm gonna create a function. Create a for loop that goes through single digits and prints out each one. And I'm just gonna call it print list, and it's gonna take in a list, and we're going to print. We're gonna say for item in list, print out item. And then at line 6, we're going to call the function print list. And we're going to target our single digits, right? Should print 0 through 9. Let's run it. Item. Because again, we got to put parentheses. This is just like C++, where I'm forgetting my semicolons everywhere. Cool. So, both unit tests are passing. Let's go to 3, create a list called squares. Okay, inside the loop that iterates through single digits, here, this loop, append the squared value of each element of single digits to the list squares. You can do this before or after printing out the element. So what we're going to do is append the squared value. So we're going to take whatever the value is of item, and we're going to square it, and we're going to append that to squares.append. And then we are going to unit test it. Should print the square of 0 through 9. And we're going to print list. And we're going to, again, pass in single digits. And this unit test is no longer valid. We're going to run it. Single digits is not... Where? Print single digits. Run. Okay. So the question is, did it print out the square of the digits? It did not. So it did print out the items. You know what we didn't do is we didn't print squares, the list squares. Let's run it. So squares printed out nothing. So this did not work. So we can plus equals, right? Oh, insert. All right. And let's run it. Invalid syntax, right? Because I put a parenthesis here. Let's rerun this. So again, the output didn't print anything. So item isn't being squared properly. And it's certainly not being added back to squares. So squares, let's run. Nope. So inside the loop, append the square value. Create a list called... Okay. So here's what we're going to do. We're going to create something called new value. And the new value is going to be equal to wherever the item is squared. Okay? Then we are going to append squares with the new value. And then we're going to try to run it. And we still get nothing because we did not print out squares. We did print out squares. After the for loop, print out squares. So now this could be a scoping problem, perhaps, where squares doesn't exist, so it can't see it. Let's see. I think what the problem is that squares is not defined. What are they talking about? Let's run. Inconsistent indentation. Run. The name squares is not defined. Something doesn't seem right here. Let's try this again. Try that again. Squares is not defined. Squares is defined right here. It's equal to an empty list. We can even print it. Print squares. Run. Doesn't print it. Okay, let's reset the exercise. Okay, let's start at the start. Let's start again. So single digits is going to be equal to a list that has a range. That range is going to be between 0 and 10. 0 and 9, right? And then we're going to put a unit test here. And we're going to say the first one is print single digits. And then make sure we come back and we fix this and rerun it. But bam, cool, create a loop. So we do this outside of function. So for digit in single digits, we're going to print digit. Boom. Create a list called squares. Squares is equal to an empty list. Run. Inside a loop that iterates through single digits, inside of here, append the square value of each element, single digits, to the list of squares. Oh, you know what? This was a nested loop. Right? Right. For each square in digit, we can take squares and append the digit squared. And I think this is where we went wrong. Right? Int is not iterable for each square in digits. Digit times 2. Int object is not iterable. Oh, you know why? Because each digit, it comes out as a single number. So I wonder if we can just come back here and do this again. Let's run it. And can we print squares and run it? It does print out the squares. Holy smokes. This has something to do with Codecademy, I think. I think our function worked just fine. Okay. So should print 0 through 9, and then should print squares of 0 through 9. Create a list called cubes. Each element of cubes should be an element of single digits taken to the third power using a list comprehension. Remember, in list comprehension, we have to do the calculations first. So digit to the third power. Remember, digit to the third power for digit in single digits. And then copy this, paste it, and change squares to cubes. And then, what? Is insert back on? It was. I don't know why I had insert on. Should print the cubes. Let's run it. There are these cubes. These are cubes. Cool. So this is dirty. So we're gonna clean this up a little bit. For a couple reasons. Again, this should have been a function. Should have been a function because you add these into the function. But print cubes. Good job. Hey, okay, we've completed this. So again, super useful here. You do the calculation first, and then you put for whatever it is you're iterating from the list. So item in the list of items. So for this is saying take an item and cube it for every item that's in the list of items. And in our case, our list of items is 0 through 9. Awesome. So I'll be back hopefully with Kevin. He should be get home right about now, and we'll take a look. We're gonna build an application called Carly's Clippers.